This video is going to cover the topic of writing expressions with percents. Be sure the date and topic are at the top of your page. The essential question for the video is how and why do we represent percentages in algebraic expressions? And of course, we worked with percentages a lot in 6th grade. So we know that a percent is really just a ratio, but it's a specific ratio out of 100. And we use percentages to find values for numbers that aren't out of 100. So for example, if a student correctly answers 19 questions out of 25 on a test, we could say that that means that they got a 76%, right? And it doesn't mean they did 100 questions. It just means that if we scale that up, we know that it would have been 76 out of 100. And of course, percentages mean out of 100. So that means when we are writing ratios, writing percents, we could write 60% as a percent, but it really means 60 out of 100. And therefore, it could also be written as 60 hundredths or 6/10ths, right? These all mean the same thing. And this is important because when we use expressions in algebra, we're going to be using this decimal form. Let's quickly write these percentages here in decimal form just to kind of practice that. So go ahead and jot these down as decimals. And notice for this last one here, 120%, well, two things. This is more than 100%, so I have a 1 in my ones place. And then I have it written with the zero here, and then I also have it written without the zero, and they both mean the same thing. So be mindful of that. You'll see that lots of times going forward. Percentages appear a lot in the real world, in places like shopping, banking, taxes, your percentages that you see in sports. So I'll use a couple of those examples to show you what that looks like when we talk about it algebraically. When you go shopping, you'll often, hopefully, be looking for deals, and you might be seeing when things are on sale or on discount. For example, a pair of shoes might normally cost $50, but then you'll see that there's a sale for 25% off. And so we need to make sure we know how to find the new price, and I'm going to show you two options. I might say that I want to find 25% of, this means of, so I'm trying to find 25% of my $50, and I would do that by turning this into a decimal and multiplying, and I'd see, oh, that's $12.50, and that's how much I'll save. Meaning, of course, that if I take away my savings, my price would be $37.50. On the other hand, I could say, hey, if I'm saving 25%, the shoes were originally 100%, and I saved 25%, I'm going to have to pay 75% to get my shoes. So I could take my $50 and find out what 75% of that is, and I would calculate that with my phone or my calculator, and I would still end up with the same price, right? It might just be one step shorter. And now I'll show you how we can generalize that for any pair of shoes at any price. In my first example, I took my original price and I subtracted it. Remember up here we did a little bit of subtraction, right? I subtracted that by what I got when I multiplied my price by 25%. That's what this expression here does. That's option 1. Of course, I know that there's actually kind of an invisible 1 there right now, so I could also combine my like terms and say 1x minus 25% of x, and that would be 75% of x, and that is option 2. I could just simply multiply my price times 75%. So this would work for any price shoe. I could just plug that in and solve. Percentages come up as well when we're talking about tax, and I'm going to use California here since we don't have tax in Oregon, but there's a 9% sales tax at restaurants in Los Angeles. So that means in addition, right, they have to add on 9% more to their bill. And this time I'm going to start algebraically, and I'll just use M for meal, right? So if I have a price of a meal, I'm going to be starting with the price of my meal, but then I have to add on 9%, remember that's how we would write 9%, of that meal to my total. And of course, I could also think of this as 1M, which means I could combine these like terms, right? Adding my 1 and my 900ths, and say that I could have this as my expression, right? I have to figure out how much my meal is, and then multiply it by 1 9/100 to figure out my final price. If Jacob buys a sandwich for $12, I know, since we've practiced substitutions, that I could take this equation that I wrote, either one, right, the first one or the second one, and I could plug M in with $12, and I could punch it into my calculator. I could do whatever I need to do and find out that his whole bill would be $13.08. And if someone else's bill, say Koa's bill, was $20 for what he purchased, I would substitute 20 in instead, and again do my calculations and find my total amount is $21.80 in that case, right? So I can just take this equation and plug in anything I need to solve. We also see percentages with commissions, which is a percentage of a sale that the salesperson gets to keep, and it's, depending on the business, a different percentage. A real estate agent that sells a house generally gets to keep 6% of the price they sell it for themselves. So we know that if they had a house for C dollars, they would be able to keep 6% of that, right? So that would be the expression that we would use. And if they sell a house for $100,000, right, then we would take this equation and we would substitute in $100,000, and then we would be able to figure out that that would be $6,000 that goes to the agent, right? They get to keep that, the seller keeps the rest. Pretty easy calculation if we have an expression that we can just plug it into or substitute into. We also see percentages in what we call markups, which is when, this is how businesses make their money, right? They buy something, they sell it for a higher price, and they keep the profit for themselves. Which means if Carolyn buys a hat from a wholesaler, right, and then she wants to charge a markup to be able to make a profit, that means she's going to charge the price of the hat plus an extra 30% of the hat, or in other words, she'll sell that hat for 1 3/10 of the hat's original price. If Carolyn bought that hat originally for $40, we know that she's going to take that $40 and multiply it by the whole and 30% more, and then we could just punch that in and she would be selling her hat for $52. Now these are 4 examples of when I've used percentages, but there are so many other ways that you might use percentages. This is just supposed to give you an opportunity to see how we turn them into these algebraic expressions and how that can really make it easier for you to find your total values, right? It's super fast once you just plug or substitute in something. So lastly, just try to write an expression for yourself. And I don't have any prices in here because I don't actually need you to tell me what her final price is. I just want an expression that will be used if Maddie wants to buy a sweater and all we know is that it's some number of dollars and it's 40% off. Your job is to write that expression that would be used to calculate her final price, of her sweater. And remember, the essential question of the video was how and why we represent percentages in algebraic expressions. The why is that I think it makes it a little easier. The how, of course, we will practice more in class.